Hello and welcome to the new video, and this video is about a SMACNA fitting, a SMACNA duct fitting. And this is the fitting. So it's a rectangular T, and the thing is that the 45-degree anti-branch is connected on a tapered side of like a reducer, or you can say a transition. So I have been asked to make this fitting in not only just a fitting but also do the pressure drop calculation as per the SMACNA tables. So which I'm going to show in this video, that how we can do a duct fitting with its different table, because as we know that inside Revit all the duct fittings, they are done based on ASHRAE. So a client of mine, he asked me if I can do with the SMACNA. So I am going to start a new series of how do we do what I do with this SMACNA fittings. So, and I can do the calculation using these branch coefficients and also the interpolation of the values between in between values. So that's what I'm going to do. So here I have two rectangular ducts, and this is 3D, and inside the duct I have loaded my this T, which I have made it already, this T. And the interesting thing about this fitting is that here it is written the flat side of the duct, this one, the 45-degree entry branch, is connected to the flat side of the duct, whereas the other three are tapered. On other three sides of slope, or they have taper. So this is what I'm going to show. So what I'm going to do, this fitting also works with routing preferences. So that is the fitting, and here this is the inlet side, this is the outlet side, and this is the branch side. So as of now I can bring my tag here as well for the duct tag, and as of now you can see there is no flow rate inside the duct. Now I'm going to introduce some kind of flow inside the duct. So what I have here is an air terminal, so I just can quickly grab the duct and introduce some airflow. So right now you can see this is 1025, which is quite high. So let's say I do this 950. All right, so the flow inside the duct changes, as you can see. And this side I have here this an inlet and this outlet. I can decrease the outlet, so I can select the size, and let's say this side is 650 by, let's say 400. Yeah, and I have here right now again zero airflow, and I can bring my A terminal here, and then I can change the value here. So let's say 1150 liters per second. So now the thing is that for me to do the pressure drop calculations as per SMACNA, which is this, what I have to do is that I have to select the fitting, and here because this is the by default method in Revit, that Revit will tend to choose the correct fitting or correct table as per ASHRAE. So if I choose if I see this here, let's see which one is so it is picking all of these three, so I can choose any of these things. But the thing is that he doesn't want the calculation to be done as per ASHRAE. He wants to be done as per SMACNA. So what I have to do is that I have to come here and select not defined. Now the thing is that for me to do the calculation inside the Revit, I must have the flow rates of inlet and outlet and the branch inside the fitting somehow, right? And that's how I will going to get these flow ratios from branch to inlet and outlet to inlet. And then I have to do, I can grab the loss coefficient here, right? So if I select this fitting here, so you can see in mechanical flow I have all of these airflow rates in their respective terminals, right? So inlet is QC, which is 2100, which is the sum of this, and outlet is QS is 1150, and the branch is 950. So all the necessary calculations are being done within the family. So if you can see that I have everything calculated here, QB, QC, 0.45 and 0.55, right? So QB, QC. So here the table is just giving me the values between of 0.4, 0.5, 0.6 and all from this. So I have interpolated the values also in between them. So for example, right now here my QBQC is 0.45, right? QBQC, which is Q by divided by QC basically. So I'm just using underscore. So it is QBQC. So 0.4, 0.45. So C, it has to be between these two values. So if we do the interpolation in between, so it will be something like 14.5, 0.63. It should be 0.63. So this value should be 0.63, right? So here we can see what is our this value is 0.62, right? And so that's just same way CS has to be 0.2 because of 0.55 of QSQC, which is here. This is 0.55, so this has to be also 0.2. And also if I do now do the system inspection, and I have these all pressure drop calculation and the actual values calculated here as per SMACNA inside the fitting, and I can go inside analyze, and I can go here duct pressure loss report, and I can choose this system, and I can generate this to be, let's say, this one, and yeah, here it is. So as you can see here that I do have these pressure losses as per SMACNA inside the fitting. Now the thing is that somebody might wonder, where do I get these loss coefficients from? Because these loss coefficients were not seen anywhere here, or whether inside my fitting. Now here the answer is that SMACNA works differently than ASHRAE. So in ASHRAE, the thing is that I'm going to show you here. In ASHRAE, what do we do is that we multiply the velocity pressure of this side with the loss coefficient of this side. But the thing is that in SMACNA it's different. In SMACNA, it has the note for all of this. So it says that use the velocity pressure of the upstream section for fitting loss. So you multiply the velocity pressure by of the inlet section here only with whatever loss coefficient you get, whether it's for the branch or for the outlet. In ASHRAE, you multiply the loss coefficient of this side with the velocity pressure of this side, and likewise here. But in SMACNA, you have to multiply the loss coefficient of this side, this side, with the velocity pressure of only this side. So because of that, it is Revit is anyway again calculating the correct loss coefficient to give me the pressure drop here, right? But the thing is, this calculation is correct. So if I choose here, even in my losses are being shown here, whatever you see here in this, which is 12.1 pascals and like 4 pascals, I do see them here. So here they are. So I have put pressure drop of branch and pressure drop of outlet. So this is very interesting thing. So maybe I can change the size, I can change it, works with the routing preferences, and here you can see that my 45-degree inlet is connected on this side, which is a straight one as mentioned here. So yes, it is possible to do fittings loss pressure calculation as per SMACNA. All the calculations have to be done inside the family. So this is it. I just wanted to show you this. Yes, SMACNA loss pressure calculation is possible inside Revit. Thanks. Have a nice time.